Okay. Get a wet area presentation. I think as well. No. So I've got this, wet areas presentation under building approval, but because with project 2 we're touching on wet areas as well in terms, like you're not going into nearly the same sort of detail you are with building rules, but we might as well cover that all today anyhow to give you an idea of where all the information is located. And I did a similar thing for the students last semester. So some of the students that are doing building approval now did planning approval previously, and so I don't want to be going over this in too much detail in the class, and several students have already been through it fairly well. So for our information sources for wet areas, we're drawing on 2 information sources, so our National Construction Code and our waterproofing of domestic wet areas, so AS 3740. So I've got volume 2 there. That's for detached residences, well, or solar occupancy units. But with your project 2, essentially you'll be referring to NCC volume 1 because it's a class 2 dwelling. So this is so volume 2 is for class 1 dwellings. So our 174 Shepherd's Hill Road, but volume 1 is for our class 2 to 9 dwellings. Essentially, though, the makeup is the same. We'll go through that. So one of the big differences between volume 1 and volume 2 of the NCC is volume 2 is in parts, like numbered sections, whereas volume 1 is in lettered sections. So when you're referring to any of your compliance aspects within your plans, it's important to have a separate set of notes for class 2 to 9 as it is for class 1 and 10, because all of your NCC provisions will be referenced numerically for class 1 to 10 and alphabetically for 2 to 9. So remember that. Within our NCC, we've got the section health and amenity. So if I open up that NCC volume 2, so get your contents tags happening here on the left-hand side from this little tag there. Open that up and then scroll down to health and amenity. And then within health and amenity, we've got wet areas and external waterproofing. So this relates not only to what's happening in bathrooms, but also to what's happening on balconies, etc. That's going to be an important thing for project 3. So keep that in mind. We can touch on that again for building rules consent when you get to that point. But you've got provisions for waterproofing in both internally and also externally. And I've found through experience that if waterproofing is forgotten somewhere, it's typically forgotten when it's external applications, and there are ramifications from that. So we go to section part 3.8.1. Yeah, go back to our. So within that, the important point is 3.8.1.2, wet areas. Building elements in wet areas within a building must be waterproof or water resistant in accordance with table 3.8.1.1 and comply with AS 3740. So that table is included within the NCC, but that same table is also included within AS 3740 as well. What it provides us with here is 2 distinctions: waterproof and water resistant. In compliance, are you covering wet areas in compliance? No? Cool, that's fine. So is everybody aware of the difference between waterproof and water resistant? Or,
Not
no,
not
in a material sense.
Regulated, not in a regulated sense.
Yeah. So whenever we build a bathroom, for example, we can't just use any normal plasterboard within the bathroom. Well, we can. We can use normal plasterboard for a portion of the bathroom, technically. Not that you would. I mean, to save a couple bucks, you probably wouldn't do that and go through the bucking around of changing out your plasterboard part way through the bathroom. So essentially, the whole bathroom is done with some sort of water-resistant lining. So that be that a fibre cement sheet for extra strength and stability, or a water-resistant plasterboard. In terms of that water-resistant plasterboard, you can also get fire-resistant and water-resistant plasterboards as well. The reason for that is for apartment constructions, whereby you have to have fire-resisting walls and you use fire-resistant plasterboard. That enables bathrooms to be close to that fire-resisting wall. So you can get water-resistant and fire-resistant plasterboard.
But wouldn't fibreboard? I mean, like
Fibre cement.
Fibre cement. I mean, if you whack up 6, you're covering FR, the fire rating levels in bushfires just with 6 mil cement. Fibre cement. So why would you go for water-resistant and fire-resistant plasterboard?
Because fire separation in buildings is not the same as building in bushfire-prone areas. Right. So your 6 mil fibre cement sheet in bushfire-prone areas up to flame zone is suitable. Mm-hmm. So once you get in flame zone, then it changes, and it's a little bit more detailed. You've got to have FRLs for that. So what we want to ensure that and this is very pertinent to Project 2, because we've got to ensure that there are fire separation walls between each unit to achieve separate title. Those fire separation walls, basically, hardly anybody, no builder or architect, or very few, will go and design their own system for a fire resisting wall to achieve those FRLs, because the testing required is massive to simulate a fire situation, measure the amount of heat coming through, measure the gases passing through, and to measure any breakdown of that system over time. People aren't going to do that themselves. What they do is they rely on that work that's being carried out by manufacturers. Typically, all of your plasterboard manufacturers will have fire-resistant wall details. So rather than go through that process, you buy a system, essentially. Now that system that you buy might be from CSR, might be from Boral, might be from Hebel is CSR anyhow, but it may be a plasterboard system, it may be a Hebel system. Either way, you're going to have a look in your reference literature to work out, okay, if I have 2 layers of fire-resistant plasterboard and this particular insulation and another 2 layers like that, then I get an FRL of 180, 180, 180. That's suitable for this situation. So hence that's why you follow the dots or follow that procedure thoroughly as it's set out in the Red Book or your Boral installation guide for fire resisting construction. While we're talking about Boral installation guide or Red Book, also good resources for this information. I didn't put those in as sources of information, but they also provide some good simplified details of where something needs to be waterproof and where something needs to be water resistant. So that's another source of information as well. So we've got our waterproof and our water resistant. So we do our whole bathroom in water resisting plasterboard, but that's not where it stops, because there are sections of our walls that also need to be waterproof. So water resistant, if you get water on there for an extended period of time, water will start making its way into that product. But if we put a membrane on that product, a painted membrane on that, then you can keep exposing it to moisture thoroughly without any of that moisture passing through. Typically that's what's used, is a painted on membrane that's flexible and provides that continual waterproofing. But if we have a look at the table 3.8.1, it says we can also use products such as copper. So we could use copper sheet, for example, for waterproofing, or there's a few other things.
An expensive way of waterproofing.
Exactly, very expensive, but what it does, it enables different approaches to things. So, yeah, so you could...
Small and discreetly used bits of copper.
Exactly, yeah. So, as we work through, so we've got, it says, to comply with AS 3740 and this table. That's all fairly standard. Basically, the take-home message from that table is that you're going to use a waterproof membrane to achieve that waterproofing where you need to, and then water-resistant linings everywhere else. Actually, let's have a look at our table 3.8.1.2. What was it? So 3.8.1.1 table 3.8.1. Where is it? That's not taking me. That's.
Some of those are going to start with.
Yeah. All right. We're going to have to scroll through, find our table 3.8.1.1. No, that room heights. Table 3.8.1.1. So, that's notes table.
No, it's literally saying replace it with the words below.
What's that?
It's literally saying in South Australia, replace it with the words below.
Oh yes, yeah, and we'll get to that in a minute. I was just wanting to get to this particular table.
Is that
right, what's that? Yes, yeah.
Why don't they never actually? Why don't we waterproof kitchens?
What's that?
Why don't we waterproof kitchens?
Well, in South Australia we do.
Oh.
Yeah, interesting enough. Yeah. No, thanks Anthony. No, the one I was looking for is actually the table of what's waterproof and what's water resistant is actually in AS 3740. So head to that. Materials, page 9. Go down to that. So we've got a list here of water-resistant substrates, and that's made simple simply because you don't go making your own water-resistant substrates. You buy plasterboard, you buy fibre cement sheet.
Or you put down a concrete slab.
Yes, yeah. So masonry in accordance with AS 3700, water-resistant plasterboard, fibre cement sheet manufactured in accordance with AS 2908.2. True. So different materials considered waterproof or water resistant for walls and for floors. So for floors, maybe structural plywood manufactured in accordance with that and installed in accordance with AS 1684.2. So that's water resistant, and then waterproof. So waterproof, we can use stainless steel, copper, flexible waterproof sheet flooring material with waterproof joints of the sheeting. So some form of linoleum product that has adequately sealed joints, and then membranes meeting requirements of AS 4858. So that's typically what you're going to use.
And those are painted. Do you use because it's like on tiles? Yeah.
Yeah. So you Yep, so you paint that in underneath. So with our wet areas, so there's this table saying where we have to waterproof and where we have to make water resistant. However, I'll simplify that a little bit, because when we have a look at AS3740, it actually gives us details to that effect. Go through. So in the appendices, it shows it in a diagrammatic fashion of which areas need to be waterproof and which areas need to be water resistant. So water resistant to our walls here, which will be a water resistant plasterboard plus tiles on the top. And then waterproof to our joints to 40 millimeters either side of the joint. Waterproof around our taps and penetrations, and then waterproof to any of our floor joints. That's in the case of a shower over a bath with an enclosure. Then if you move down to a shower over a bath without the screen enclosing it, you need to have your waterproofing to 1500 from the shower rose. So that floor has to be waterproof to 1500 around the shower rose. And then with any open shower, like let's I won't keep scrolling through to find them, but let's remove this bar, it's the same. So waterproofing to 1500 on our floor or 1500 radius from the shower rose. But with our, and I've got it in this one here. I'll get back to those state and territory variations in a minute. With our waterproofing membrane, there are two approaches. One, we can paint it directly onto the slab and then do our screed on the top. That means that our tiles will shed most of the water, but then there's some bleed happening into the screed. So that screed will stay a little bit wet. And in high volume uses, that screed will bleed more moisture. Or we can do our screed underneath and then do our waterproofing membrane on the top and then tile directly over it. Your choice between these two methods is typically dictated by what sort of outlet you want to have in your floor. If you're going to be having a strip drain, well then you're going to have to waterproof underneath the screed. If you're not having a strip drain, but you're in an area that has a lot of soil movement, you'll probably want to waterproof right on the top. The reason you waterproof right on the top for areas that have a lot of soil movement is because quite often what you get happening is your screed will loosen itself just slightly as the building does a little bit of flexing and things, because concrete slabs do flex a little bit, and you get your membrane tearing at where the screed is going over top of your concrete. So that's the better detail for high movement areas, but you can only do that sort of thing if you're going to have your waterproofing membrane lapping into a floor trap that's at the surface. This is the detail you have to have if you're setting in a strip drain, where you're going to be collecting some water out of it.
Is a strip drain like long drain?
Yes, exactly. Yeah.
But why would that be a problem in terms of waterproofing? I don't understand that. I don't physically get why there's an issue with you, as opposed to having a drain that goes straight to the floor. You have a strip drain, which obviously has to drain down into something that goes straight to the floor.
Yeah.
What's the difference?
The difference with that is that you can't lap your waterproofing membrane into your strip drain in the same fashion that you can lap into your standard sort of outlet.
Got it.
So it is also good practice to have a bit of waterproofing membrane coming up to your strip drain as well on the top if you can to avoid moisture ingress into that. But we'll get into puddle flanges and things a little bit later, and I'll show what a puddle flange is and how that works in concert with these things. But basically with with whatever the drain requirements you're designing for in your bathroom, think through that process and read the manufacturer's specifications as to where you need to be waterproofing, whether it's waterproofing under screed or waterproofing above screed. There are also different practices state by state as well. From what I understand, this is typically what's done in South Australia, whereas this is typically what's done in New South Wales and Victoria. But those practices are sort of developed differently because of different building products and so on available, and things change a little over time. Anyhow, so that's, although, yeah, the point I wanted to make with showing these though, is that if we go back to AS3740, where it said 1500 radius from the shower rose, when we have a look at this detail here, we're bringing a waterproofing membrane up to the edge of the tiles with a thing called a water stop. Now that water stop is just a piece of PVC angle or plastic angle that's fixed to the slab, and then the waterproofing membrane is painted over it, and that carries to the top of our tile work. So if we've got 6mm tiles, then we bring that water stop to 6mm above our screed, and then our tiles go to that. We don't want that water stop protruding past the tiles, but we also don't want it underneath the tiles either, because we'll get water bleed through there and it'll compromise that. The reason we have a water stop is because if there's any moisture that's making it into this screed, that can transfer in both directions. And we don't want that water or that moisture transferring through our screed into our timber framing at the edge of the bathroom. Or our external walls, because typically you have a set down that goes into the building, but is sets down your external wall at that portion. So we want to stop that water migrating through our screed. That's done with a water stop.
Does that always have to be PVC, or sometimes is it like stainless steel? Or
yes, exactly. Yeah, so you can use other products like stainless steel. I think I'm not sure if you can get aluminium ones as well. I think I've seen.
I've never noticed like PVC sort of extruding out the boundary of a wet area, but you see all the times like steel sort of edging at the end of where tiles start or whatever.
And that's the water stop. So stainless steel ones, but you get plastic ones as well.
I think it's one of a lot of the time. It's just easier. I mean, particularly if you're doing it on the surface, you just do the whole wet area. You don't worry about 1500 millimeters. And
that was the point. I was going to get to.
Perfect curve.
Exactly. Like, so let's say we're using stainless steel for our water stop, our little angle. We're not going to curve that to a 1500mm radius and then cut all of our tiles to a 1500mm radius to meet that. So although we see that that's what's stipulated within AS3740, this 1500 radius, what happens is a straight line from here and a straight line from there. If someone's being stingy with the waterproofing material. If the waterproofer or the waterproofer and tiler is going to be generous, they'll put a water stop right at the door, and that's it. Screed all the way to the shower, and then paint the whole thing with waterproofing membrane.
And that's actually a much cheaper way, because you're saving on all the detail labour that you just don't even need to do.
Yeah, exactly. So you're saving on labour. You spend a little bit extra on materials, but $50 extra on waterproofing membrane or so. If you're saving yourself several hours in messing about with trying to screed over top of a waterproof water stop that protrudes slightly higher from the screed, all that sort of stuff.
Yeah.
So although that's what's set out within AS3740, typically what will happen is water stop at the doorway, and then the rest of your floor waterproofed, and that waterproofing membrane turned up the sides. So for planning approval, you're required to put in information in regards to floor slopes and for waterproofing. So we've covered the waterproofing thus far. What you can do is you can work your way through AS3740, and because Revit enables you to import images you can import images from here to show your waterproofing detail. So typically, what we always had, because we used AutoCAD for all of our work in the office, is we have 3 pages of waterproofing details. So those 3 pages, they get attached to every single project. What you can do with Revit makes it a bit simpler to compile these things as you go. So you can get those diagrammatic representations of what's required for waterproofing from here, or you can get them from your Boral installation guide is also a really good one for waterproofing details. I think CSR Red Book has plenty of waterproofing details in it as well. So yeah, several different sources. Anyhow, you can make your way through here to highlight exactly what needs to happen with waterproofing. But yeah, one thing I'd want to make note though, while we're talking about it, because we're talking about waterproofing, because with Project 2, planning approval students have to detail waterproofing and floor slopes, and then building approval students have to do it for Project 1. So you'll be looking at Volume 2 NCC for that, and doing your design based on this. This is all fairly simple. For Project 2, because you've got a disabled bathroom, or at least one disabled bathroom, the thing about disabled access is that you can't have any steps greater than 3 millimeters, or transitions in floor level greater than 3 millimeters. So what that means, and also you can't have enclosed showers. So your shower, to meet disability standards, can't be an enclosed shower. So that means that all of your entirety of floor, basically, it has to be waterproof to 1500 from the shower rows. But what you'd also notice with disabled bathrooms is the requirement for those disabled bathrooms to have that shower rose on a hose. And that shower rose on a hose has to be 1200 long.
Means it 12. An extra 1500 long, however far.
Exactly, yeah. So we've got 1200 plus 1500, so 2700 radius from the shower rows. Yeah, we're waterproofing the whole floor. And that's so.
You may not even have 2700 in your entire bathroom, but
exactly. So for Project 1, building approval, I'm happy with importing these details and saying this is what needs to happen. And then the builder can interpolate from that and say, okay, well, we've got this open shower, we've got these joints, etc., and they do their waterproofing as a result. That's fine. For Project 2, you're going to have to specify waterproofing for the entire floor, and then also slope for that entire floor as well.
And as standard, you've also got to think about the reinforcement of that back wall, any wall the wall that's attached. I can't remember which wall it is, but there's walls that need to be reinforced. Because of the weight thing.
Yeah. So yeah, that's for in timber framing. What you're not required to do for this planning and building approval subject is show your timber framing details. But if you're doing a wall framing plan for building, and you will have to do that for building rules consent when you do it in the real world, is you have to set out your studs. Typically, for all of your walls, everywhere your studs are at 600 centres. So even if your wall is not in increments of 600 mil, let's say it's 5.8 metres, your studs are going to be 600, 600, 600, blah, 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 and 400 for the last one. The reason for that is because plasterboard sheets come in 600 millimetre increments, and you do all of your butt joins of your those sheets, do them in between the studs, and with back blocking on them. So all these sheets are in those 600 mil increments, so you set out all your studs at 600 centres, except for when you get to wet areas, because there's an additional weight on those walls from possibly thicker moisture resistant linings, but then also the tiles. So the tiles impose a weight, so that means you have to set all of your studs for wet areas at 450 centres. what I've typically done is with my framing plans, I actually set out where the studs go. Because it's a fairly quick process, and you can work that out. You work back from your openings, etc., and set out all your studs, and you set them out at 450 centimeters. Or you can do it simply by having a framing plan that shows where all your lintels and important bits of information go, and then you say studs at 600 centimeters to main of dwelling and at 450 centimeters to all wet areas. That's also that possibility. But yeah, good point. So we've got our details for our Class 1 building waterproofing, and you can adapt and modify these details as well for Project 2. Just thinking that you'll have to be specifying that you're waterproofing the entire floor, and that you don't have any floor transitions or step downs. You're sloping the whole floor from the opening, and that you don't have any shower screens.
Does that, I forget what you called it before, but the edge, the PVC edging, does that have to be a step down, or can that be flush, like at the...
That has to be flush at the top of the tiles.
Okay.
Yeah. So you can have a water stop within your floor, but the reason you waterproof the entire floor for disabled bathroom is that hose. So 1500 plus 2700 plus 1200. Yeah.
But I was just thinking, like, the entry to the bathroom can still be flat.
Oh yes, yeah. So,
is.
and that's the thing. I'm not getting you to work through this scenario to that sort of detail, but if you were actually doing this project in real life, that is something you'd definitely be looking at very early on in the project. Is our floor set down adequately? Like, is our slab set down adequately for us to be able to have the falls to the drain without having any step up as we enter the bathroom? Because within a disabled apartment, you can't have any transitions in floor level greater than 3 millimeters. So you definitely want that your floor from your main dwelling or main portion of your living areas to be exactly the same height as the start of your flooring for your bathroom.
Is that step a literal step or a slope? So it can't slope more than 3 meters from one point?
Oh no, it can slope. Yeah.
I
don't have the Australian standard for disabled access here lined up. So try to think of it off the top of my head, but it is actually a 3 millimeter step. So you are allowed transitions, and there's and that's detailed to the extent you're allowed transitions as well. So that's our wet areas, and this table. So as I mentioned before, this table sets out waterproofing requirements for all of those situations, but you can also look to get it diagrammatically there in AS 3740. But as with just about everything in the NCC, every section, there are state and territory variations as well. So for South Australia, for the rest of the country, we've got our wet areas, so shower area, baths and spas, etc. Other areas, laundries, and no mention of kitchens whatsoever. And within laundries, it's water resistant floor of the room, and no mention of, we'll get to some other bits that we have to do in South Australia as well. Within South Australia, added to that, it's in any room containing a washing machine, the wall from the finished floor level to a minimum of 75 millimeters above and 75 millimeters each side of the washing machine tap outlets must be water resistant. So in the rest of the country, we don't have to waterproof around washing machine taps, whereas in South Australia we do. So that's why you have sections of tile on a wall in a laundry now in South Australia, because we have to waterproof to 75 millimeters. Was it to a minimum of 75 millimeters above at each side of the washing machine tap outlets. Keep in mind, typically your tiles come in 150 millimeter increments as well. So typically you're waterproofing to a larger area. And that's, yeah.
Sorry,
Yeah.
do you think like a solid splashback that's like, I forget what they call it, but you know,
Glass.
that aluminium, yeah, a glass
yeah,
splashback with
yeah.
aluminium. Do you think that also acts as waterproofing if it's sealed right to where the tiles begin at the floor? Like, so you didn't actually have to waterproof membrane the walls because that goes to the height it needs to be, down to the tiles on the floor, and if it's joined properly.
Yeah, really good. Yeah, really good question. That would come down to the product manufacturer. So if that splashback was manufactured splashback, it'd come back to them providing that certification to the private certifier. So within their product literature, they would say this complies for waterproofing to this, and so yeah, so you don't have to use that membrane.
Yeah.
Yeah, and it will do that. And that's something which I think is really quite topical now, because people are using really large format tiles in showers and things, to the extent that I've seen in some showers panels that go to 1800 high and then go all the way to the floor. So yeah,
That's a big piece of clay.
it is and unfortunately the place I saw it in, that was a place, it was an addition on a house, and it had moved ever so slightly and it cracked. Yeah, very expensive things to buy as well. So yeah, you're not only going to use that sort of thing if you know you're going to get no movement whatsoever. But those products are out there. Yeah, as far as I'm concerned, I think that does provide a very good waterproof barrier. But you'd want to have that certification from the product manufacturer. Another thing we've done recently is used a silicate-based sealer that soaks into a concrete slab to ensure that slab is actually waterproof. And so that's something that's not mentioned in NCC or AS 3740, but the manufacturer of that product says, yes, if applied correctly, that silicate-based sealer provides waterproofing to the extent required under the NCC. So the product manufacturer gives that warranty, and then that's enough for the private certifier.
So we don't need cladding if we use that product?
Well, if you use that cladding, if you use that product, what that means is you can have a burnished concrete floor like this that you use in a laundry or in a kitchen. So, yeah, technically, you see it done a lot that people are just doing burnished concrete floors without adequate waterproofing to meet the code. But yeah, if you want to meet the code, there are these products out that you can be sprayed on that soak in, and you don't see them as a gloss. It just looks like that burnished finish, but it's actually waterproof. Another thing, so you have to provide waterproofing to those floors in your kitchen and your laundry as well in South Australia. So where a vessel is inset, bench top, kitchen, bar area, kitchenette, or domestic food and beverage preparation area, wall joints, etc., and perimeter edges, and then penetrations, horizontal surfaces, taps and spouts, outlets, etc. So where floor wastes provided for drainage of floors in bathrooms, laundries and floors, floor wall junction penetrations must be waterproof. So
they're basically saying in South Australia you really should, have a floor waste underneath the sink.
Not necessarily, but yeah, very good point. What you're able to do is if a facility within a waterproof area, like let's say a laundry sink, right? If a laundry sink has overflow protection, which is a little slot at the back of the tub at the top that links that tub with drainage. So let's say you leave the plug in there, you turn the tap on, then someone gives you a call and you get distracted, whatever, and that's filling up. That tub can overflow back into that overflow protection and go straight down the outlet, so we're not flooding our laundry. If we have overflow protection, then we don't need to have a floor trap. So you're allowed to get away without having a floor trap in a laundry or a bathroom if you have overflow protection to all of your facilities in there. And you can also, if your bathroom is small enough, not that I'm advocating for this practice, but if your bathroom is small enough, technically you can have your bathroom floor sloping to your shower outlet, and that being your floor trap as well. So you're allowed to get away with not having a floor trap, and if you get away with not having a floor trap, then you don't have to waterproof to that floor trap and the wall junctions. So you can have overflow protection to your kitchen sink and to your laundry without having to.
Yes, it's interesting you say get away with. I actually used to manage 502 units in a South London housing thing.
Yeah.
And the amount of water problems was
Yes.
extraordinary. I mean, I'm literally talking tenants having water pouring through their roofs. So I'm a big fan of water traps for everything.
Yeah, well that's it. And yeah, I think essentially what I'm doing is I'm laying out all of the ins and outs. Because what you'll do is from here you'll go onto building sites and you'll see things and you go, hang on, they don't have a floor trap in this instance. Why don't they have a floor trap in a laundry or a bathroom? And you go, oh, because it's specified that they've got overflow protection or so. So and a lot of builders are doing this. But I think floor traps are good for exactly those reasons. Anyhow, so within South Australia, we have to be waterproofing for around our laundry sink taps, and then we also have to be waterproofing wall junctions and joints within 150 millimetres above the vessel, water resistant for the extent of the vessel, blah blah blah, within our kitchens, kitchen bar areas, etc. So we've got some waterproofing requirements in our kitchens as well in South Australia that we don't have in other states. Also, and within AS 3740, so moving on from the bits we have to have waterproof and water resistant in South Australia, we have to have floor slopes. So let's say we're doing this floor trap. We've decided to do a floor trap regardless of whether we have overflow protection on our sinks or not. We have to ensure that the floor actually slopes to that. Now within AS 3740, I'll cut straight to the mustard. It says that to our floor trap, it has to be minimum of 1 in 80 slope to the floor trap, and then minimum 1 in 100 to the floor trap, minimum 1 in 80 to the shower trap. So within our shower area, within 1500 millimetres of our shower rows, it has to be 1 in 80 to our trap in our shower, 1 in 100 to our floor, except for South Australia, and that is not included in these standard state and territory variations. It's actually included right at the end of the NCC, back here, which is I think is a very confusing bit of the NCC to say we've got a state and territory variation embedded within wet areas, and then we've also got another state and territory variation as an appendix to the NCC that relates to wet areas. And I'll quickly find that. So wet areas SA3. Actually, I'll see if I can expand that out and find it. Maybe it's that one. SA2. We get to SA3 for wet areas. We've got this little clause here. So once again, water doesn't flow well, it doesn't flow quite as much in SA as it does in every other state because we have to have our floor trap, so on our shower area, between 1 in 60 and 1 in 80. So ours actually has to be steeper than 1 in 80. So somewhere between 1 in 60 and 1 in 80 for shower area, and then in other areas, 1 in 80 to 1 in 100. So those other areas, that basically means to a floor trap. So that's on
So
page.
it's got to be 1 in 79, between 1 in 60 and 1 in 80. Well, one in 80 falls within 1 in 60 to 1 in 80.
Yeah. So we can.
That's actually a bit more. It's kind of opening up the flexibility. I mean, sort of like you can do it at 1 in 60, or you can do it at 1 in 80, or anything there in between. So it doesn't have to be less than 1 in 80.
Yeah.
It can be. So really, that's just a.
I guess, yeah, well, it's providing a parameter. It's
so
saying
like,
it has to be within this box.
I mean, I don't know why the NCC just didn't adopt their parameter, because it's a reasonable parameter.
Yeah, don't know. So this probably goes back to when the NCC was being drafted and people were getting together and making decisions about what's included. Yeah. So specifically for South Australia, we've got page 459 that says that our shower area has to be between 1 in 60, 1 in 80, and then 1 in 80, 1 in 100 floor traps. So remember that page number. Yep.
Do we have to show this, everything, the slope and everything on the drawing as well?
Yes. So for planning approval, for project number 2, you're putting in your floor slopes. So, well, you're specifying. So what I would like to see is you do a section through, you do your floor slope indicatively. Now, you don't have to do your floor slope exactly in a drawn context. I think it's always really good practice to do that, to work through, actually draw something, because then that highlights any issues later on, and issues later on abound in wet areas. So it's good practice to draw it thoroughly. However, the base requirements that I require are that you have a notation to say slope to floor trap between 1 in 80 and 1 in 100 as per SA variation 3.2.2. Well, actually, well, no, it's going to be H something or other, because it's volume 2, volume 1. But then, and then to your floor trap, slope of 1 in 80 to 1 in 100. So just have that as a note to specify what your slopes are.
So the 1 in 60 and 1 in 80 means for every 1 metre it will drop 60 mil? Is that what?
No, for every 60 millimetres it will drop 1 mil.
Okay, other way around.
Yeah, so other way around.
Yeah.
But that's still a decent, that you still have to work through that. It's still really good practice to work through that, because where we've got, and I'll talk about puddle flanges in a minute, but where we've got our drains, if every 60 millimetres you're going up 1 millimetre, and then let's say you travel 6 metres, you're 100 millimetres tall by that 6 metres. Or 3 metres, you're 50 millimetres tall already. So and that 50 millimetres, that's a fair set down. So it is limiting, and you have to think about how much you're setting down your slab to achieve that. So you're not.
But it is also where you place a drain, because if you put it right dead in the centre, it only travels, if you've got a 3 metre pathway, it only travels 1.5 metres on either side. So it's actually making sure that you get your drain in the right place to cause yourself grief.
Yep, exactly. So I think it's really good practice to actually work through these things and draw these things as well myself. Because that way you highlight any issues when it's in the drawing phase rather than the construction phase.
Is there any way to translate like that ratio to an angle?
Yeah, it is, but I don't know what that angle is.
Yeah.
Off the top of my head. But yes, you can. Yeah, you can translate that to an angle for sure. The reason I don't know what that angle is because in drafting I don't normally think in angles. It's about that distance by that, and I typically draw those things put a line in there and I get my angle.
Yeah.
I mean, it's interesting to that South Australian variation, because the thing is, if you think about it, the very wide area, you may want to do it 1 in 80, but if you've actually got quite a small area, it might actually be more convenient to do it 1 in 60. And it could be actually to do with the amount of span that you're covering, what you want to do, and you don't want to actually have to go to the 180, you know, you just do it, you know, within that parameter.
Yeah, except we'll have another look at something else now, and that's called a puddle flange. So I spoke about these in context with your strip drains earlier, because you can't be lapping your waterproof membrane into a strip drain. So with that, you have to install something like that, but it's not exclusive for use with strip drains. Obviously here we've got our standard floor trap here, like round within a square setting, that slots into our puddle flange. But what we have happening here is we have a gap between the top of our drain, our outlet, our grill, to the puddle flange. This is where we have our screed sitting. So when we do a bathroom screed, we don't start at 50 millimeters thick screed and then feather that off to nothing at the drain. We'll still need to have about 20 millimeters of screed there at the drain to provide strength to that screed. Otherwise, we'll end up having flaky, thin bits of screed that will break away and provide no strength with our waterproof membrane on top. So we have to have depth, and if we're doing a waterproofing membrane underneath our screed, well then we paint that waterproofing membrane to the top of this puddle flange, and then we build our screed up to the underside of that minus the width of our tiles. That enables any trapped moisture within our screed to flow into this puddle flange. So it flows down here, and those little tabs make sure there's always going to be a gap between this outlet and our puddle flange. So if I move up, this is taken directly from AS3740. You may want to use that detail, or you may want to draw your own that's much nicer and much better. Either way, what we've got our concrete slab here, we've got our little bit of concrete slab set down for that puddle flange, and that's a really good thing to have happen at the concreting phase. So when concrete is there, they can't go applying a 1 in 80 slope to that floor, but what they can do is just around your outlets, just set this section down just a smidge, so your puddle flange can sit in that, and then you paint your waterproofing membrane over the top so it's exactly flush with the floor level. So your puddle flange sits in there, and then your drain goes in that, and then you have a 20 millimeter screed depth right at that floor exit. So one thing the building rules consent students are going to have to do is include in your detail your puddle flange detail. So you're going to have to draw that up for project 1. Draw in your puddle flange, and then draw in your screed to that, and then have your slopes going away from that. I'm expecting that screed will start at 20 millimeters thick, and then slope away from that. The other thing that the building rules consent students are going to have to do, planning approval students won't have to do, is draw in bond breakers. Once again, this is taken directly from AS3740. So have a look at that AS3740. But where we have our waterproof membrane going along our floor and then transitioning up the wall, because it has to transition at least 40 millimeters up the wall, we have to ensure that waterproof membrane doesn't crack right at the joint. We have different classifications of waterproof membrane, but typically what's always used is a class 3 membrane. With a timber framed house on a concrete slab, you have to use a class 3 membrane, because that class 3 membrane is the more flexible of all the membranes. The reason you use a class 1 or class 2 is because of greater durability. So if I'm building an aquatic centre or something like that, I might use a class 1 membrane, something that's going to be more durable. But for our standard concrete slab with timber framed house, we're going to use a class 3 membrane because it has more flexibility. Then what we can do with that class 3 membrane to ensure that that doesn't break right in the corner where the timber frame might move just a little bit, you run a bead of silicone and cut that off as a cove. So when it's still wet, you use a little cove, like a little tool that has a rounded edge to it, and you smooth it off like that to make a cove shape, and then you paint your waterproofing membrane over top of that once it's cured. That means that your waterproofing membrane has a little bit of flexibility right in that corner there and doesn't get torn there. With a class 3 membrane, you're allowed to do this. What I've heard from other builders is that typically that's a really good detail to do anyhow, is to have a backing rod and then the tape and then your waterproofing membrane over the top anyhow, even if you're using a class 3 membrane. Enable greater flexibility. Because the thing with wet areas, if you get a leaking waterproof membrane, it's incredibly expensive to replace and to repair. So this is one of those details that many people prefer to be conservative on and use that backing rod. Legally, you're allowed to do just that silicone bead in the corner. Your class 3 membrane. So that's a detail that the building rules consent students are going to have to do. And that's it for waterproofing wet areas. Does that make enough sense and provide a clear enough roadmap to progress on with?
Is there an option on our drawing on the Revit to actually import that in, or it could just be detail lines that we'll actually make?
No, you can import drawings into Revit, definitely, yeah. Does anybody here off the top of their head know the steps for importing an image into Revit?
I just use snip tool, cut
Snip
and
tool.
paste, bring it in as an image, and then adjust it to the
Yeah,
size of
file
it.
save as image.
Yeah. Yeah. Yes.
Where can we find this?
So in AS 3740, so Australian Standards.
Applied structural, the one which is.
Oh, I've just got those on my desktop. Would you like that to be available within the Learn page?
Yes.
Yep.
Yes.
Okay. Sure. Can do. I'll put that on there. Yeah. Any other? No, it's all. Yeah. It's all fairly clear. Progressing forwards. The other thing that you're going to have, the other thing that's going to be consideration for wet areas for project 2 for planning approval is your bathroom design in accordance with Australian standards relating to disabled access. So we won't go through that today, but that's another thing you'll be looking at when you get into more detail with your project 2. What I'm expecting you to do now, or for those who are onto it, working with the bigger picture to begin with, car parking and access. So access to the property, access from the car park to the upper level, get all those things sorted, and then you'll start working with the smaller picture, these wet areas, etc. So we'll go through that later.